Okay. Question 1. Domain is the x values of the ordered pairs. So in this case, the domain is going to be, right on it, 0, -2, -3, and -4. The range is the y values of each ordered pair. Typically, we should write these in usually write these in least to greatest order. So probably more specifically, a lot of times what you'll see is write it in, again, least to greatest order. Okay, but as long as you can identify them, that's the biggest part about things. Okay. Now the equation, we talked about this the last 2 days now. How does the x, when you do something to change into that specific y? So we want to create an equation from that. And when I look at 0, 0, okay, that doesn't do anything for me. But from -2 to -10, -3 to -15, -4 to -20, what operation is happening to these x's in order to get those specific y's? And, well, I see 2 to 10, 3 to 15, 4 to 20. For me, what comes to mind is it's being changed by 5, a factor of 5. It's being multiplied by a 5. So the question is it being multiplied by 5, or is it by -5? So is x being multiplied by 5 or x being multiplied by -5? Well, think about it. If it's a -5, -5 times -2 is 10, and that's not what we have. And -5 times -3 is a 15, and that's still not what we have. So when I check that out, it does mean that it's a +5, because 5 times a -2, that checks out. 5 times a -3, that checks out. And the other one checks out as well. So as long as it checks out for all of those, you're good to go. Okay, the next one there. Classify the relations as a function or not. So running through here, number 2 is a yes. The domain, nothing is being repeated, meaning there's no additional arrow coming out of the domain for one of the values. So 10 is going to 18, 0 is going to 20, 7 is going to 2, and 4 is going to 10. That's all cool. Whereas not a function would be like 4 goes to 2 as well. If 4 goes to 10 and 4 goes to 2, that's when it cannot happen. That domain can't kind of be repeated going to different y values, different range. Number 4, vertical line test. It's a graph. We always use the vertical line test. Drag it along, and this is all good to go. 1 point at a time, 1 point at a time. That is a function. Number 5, we are again using the vertical line test. It's a graph. Use it. Drag it across 1 point at a time. Yes, 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 yes. All function, all good to go. 1 point vertically, it is good to go. So that's a yes. Number 6, that is a no. What's screwing it up? Sorry, I looked at that not carefully. That is a yes, okay? I thought right up here, I just wasn't paying attention to my numbers. So that is a yes. -1 goes to 5, that's 1 time. 0 to 3, 1 to 5, 2 to 11, 3 to 21, that's all cool. So nothing in the domain's being kind of repeated and going to the different y values. So this is a yes. Number 7 is just like the domain and range on number 6, like a mapping diagram. It's written as a table instead. I'm looking to see in the domain, is anything being doubled up or repeated? Nothing is. So we're all good to go here. That's a function. Now in number 8 though, I see 4 and 4 being doubled up. It's being repeated. Now I need to see though where that 4 is going. 4 is going to 7, and then 4 here is going to 14. That cannot happen. That's where this is not a function. You can't have 4 going to both 7 and 4 going to 14. That does not make a function. 9 and 10 are just like 7, 8, and 6. It's just not written as a table, not written as a mapping diagram. But I want to keep looking at these domains. So the domain here is what? Identify them, all the x's. And as long as nothing is repeated in that domain, we are good to go. On number 10, okay, I notice on the domain for number 10, I've got 4 and then 4, and right there is where I'm concerned. Now I got to see where that 4 and 4 is going. 4 is going to 5, and 4 is going to -7. So because those are going to two different locations for the output, that cannot happen. That is a no then. Number 11 is a graph, vertical lines. All right, use your vertical line test. And on this one here, as I drag it across, looks good, looks good, looks good. Yes, yes, it's a function, it's a function, it's a function. Oh crap, it stops. Okay, right along here, it doubles up. Okay, actually more than doubles up. It's got more than 1 point hitting this vertical line. And then it continues on right here, and it's back to being a function, but right here is where things screw up. So we say this is not a function. Okay. Number 12, draw in the vertical axis of symmetry if it has one. And the first graph does not, okay? There is no vertical axis, no vertical axis. Label the parts of the graph that are increasing, decreasing, or constant. So let's go through this. First thing you do is left to right, your eyes are starting to increase. Then your eyes are flat, they are constant. Then your eyes start to go down, and then it is flat again right here, it's constant. Then they start to go up, they increase, and then it turns and it starts to be then decreasing. So we have quite a few options in there. And identify the quadrants it passes through. Well, it goes through all 4 quadrants. Okay, and then the next one, a vertical axis of symmetry. Now this one, I think you could possibly make an argument that it could have one, but the reason why I'm going to say no is because there's no arrows extending this out. If there was, then I would say for sure we have a vertical axis symmetry. But because there's those arrows, this is kind of implying that, yeah, this graph stops right here. It's like points there to tell it to stop. So when I would try to say, hey, maybe you get a vertical axis of symmetry here, which I totally could see why somebody would say that, I'm missing this little piece over here for it to fold and match up with then over here. So I would say on this one, no, we do not. Now, if we had arrows where the 2 sides would just continue on forever, then we would say yeah. But I would say on this one, no vertical axis. Okay. I should say the word symmetry. Now, increasing, decreasing, constant. Your eyes start off by increasing, they turn and they start to decrease. Okay. And then the quadrants it goes through quadrants 1, 3, and 4. It does not go through quadrant 2. Make sure you know your quadrants. 1, 3, and 4. 1, 2, 3, 4. Know your quadrants. Follow-up question, what does the point 4,1 represent? Okay, so let's go find 4,1. 4,1 is right here. Oh, that's what they're looking for. That is a maximum. Okay, that's that idea we started talking about maximum minimums.